Now we are going to discuss in previous lectures we discussed single source storage path and problem solving, right? Introduction to uh, dynamic programming also. So in this we will start dynamic programming, right? So let's element of dynamic programming, and we will discuss the DP versus divide and conquer, and at the end we will discuss multi-stage graph also. How this works. So dynamic programming is an algorithm design method. We solve this that step by manner. If we step by step manner, never making erroneous decisions, and this is true for all problems solvable by greedy method. But all the problems does not solve by what we say greedy method. So when we are solving problem in which it is not possible to make sequence of decisions in a stepwise manner, so leading to optimal solutions is to enumerate all deci- decision sequences. All right. So enumerate is one way is enumeration. All right. So enumerate sequences, brute force it is a brute force and it becomes the best solution optimal. All right. So but the drawback of this brute force enumeration is excessive time and space requirements. All right. So for this dynamic program is used. So for this, let's say based on enumeration often tries to reduce the amount of enumeration by curtailing those decision sequences from where there is these are no possibility of getting optimal solution. That's how it may break down to time complexity. So what we can do is we will discuss it later. We'll discuss it right now. So what we are doing that right. So let's say dynamic programming DP is based on enumeration. FDP is based on enumeration. So to optimize this and to reduce some time complexity or right. So we will reduce the amount of enumeration by curtailing those decisions sequences from where there is no possibility of getting optimal solution. Right. And dynamic programming, these set of optimal decisions are made by applying principle or optimality. So so for these type of decisions we have to make, all right, to that we are not going to add this sequence or and enumeration, all right. So these decisions are taken based on by applying principle of optimality, all right, optimal structure property or global optimality, or we can say global optimality. So what is principle of optimality is principle of optimality states that whatever the initial state and decisions are, the remaining sequence of decisions must constitute an algorithm optimal decision sequence. So what we are going to what are we are trying to say is that that states that whatever the initial state and decisions are, the remaining sequence of decisions must constitute an optimal decision sequence. What I am saying that principle of optimality states that whatever the initial state and decisions are, right? Whatever the initial states or decisions are, the remaining sequence of decisions, right, must constitute an optimal decision sequence, right, with regard to the state resulting from the first decision. So we will discuss that. So essential difference between greedy and dynamic programming is that greedy method always generate only one decision sequence, right? Whereas DP enumerates many decision sequences can be generated. Alright. So let's say this is a sub problem and this is initial, alright? So what we are saying that if we let's say whatever the uh, decision we take it, this or this, the least sub problem should be what we can say optimal, right? This should be optimal. So then after this we can say before making this decision we make this also optimal, right? So this is how we do principle optimality works. It states that whatever the initial state decisions are, the remaining state sequence of decisions must constitute an optimal sequence to decision sequence with regard to the state resulting from the first decision. All right. So another important feature of DP is that another important feature of DP is that the optimal solution of the subproblem are retained, or we can say uh, cached or stored in a table to avoid recomputation their values. Invariably, their features also lead to saving of time. Right? This feature leads to saving of time. So we what we say is this memoization or tabulation we can say. So we save up the if we memoization we save the optimal solution to the sub problem, right, in a table. Live implementation are two-type top-down approach, recursive approach, and tabulation it's a iterative approach. All right. So we will see in the future how this all works. So the elements or properties of DP we will be first element is splitting of original problem into sub-problems. So what we are saying that be able to split the original problem, which means or there is a this is our original problem, all right. So we have to split this in P1, P2, different subproblems. These are all, this also will split it so that the subproblems can be further divided into subproblems. This process splitting should continue till the subproblem becomes small, right? This is how. Another element of property of DB subprogram optimality, right? Optimal substructure. An optimal solution to the problem must result from optimal solution to the subproblems with combined operation. So if a subproblem is this, if we combine this from this, if this solution should be optimal. And again, if we combine this from all these, this should be optimal. Alright. So if the solution to the subproblems uh, is optimal, if the combination of subproblem of solutions of subproblems is optimal, then then solution to the problem is also optimal. Alright. So yes, this is it is overlapping subproblem. Many subproblems themselves contains common subproblems. Therefore, it is desired to solve subproblems and store in cache result, and that's so that can be used in other subproblems. Alright. Yes. So, for example, this is a Fibonacci number. Fibonacci number is there. Dynamic programming, if we can use Fibonacci numbers, and this is a series. This is a recursive function for this. Alright. This is a recursive function here. This is how Fibonacci 0, 1, 0 less than or equal to 1 to f return n. Alright. And normal recursive implementation is this, and but time complexity of is 2 to power n out of 2 to power. So this is how we do the things. As we compute t of the log less than t1 so as than this or of right. So top down approach memorization implementation of Fibonacci n is right. We will discuss it later. What is going on here? So this is Fibonacci. This is how memorization of top down memory implementation of Fibonacci is, right? So now time is recursion stack order of n. Here is the order of n. Here, well, order of n is the time complexity is reduced drastically, right? So yeah, if n is equal to then n is 9 is equal to result. What are my approach of DPO for is to find what are my average of Fibonacci of n that n 0 is 0 and 1 where is 1 plus 2. This is how we return n command or of n only, right? When to use tabulation, when to use memorization. Resolving subproblem requires all subproblems to be solved. Tabulation usually outperforms memorization, right? Tabulation has no overhead of recursion and can use very loaded array, pre-allotted array, alright? Alright. If only some of that subproblem leads to solve or about memorization techniques is good. Right? So here what we are saying that dynamic programming versus greedy, divide and conquer. In greedy method, building up the solution to the subproblem is done by step-wise manner. Right? Applying local optimality, we can see local options only. When dividing up break down subproblems into separate problems, then solve each problem separately and combine solution of subproblems to get the solution of the problem. But with breaking up the solution into a series of overlapping subproblems and building up solutions of larger problems. In dynamic building up a problem, uh, breaking up a problem into series of overlapping subproblems and building up solutions of larger and larger subproblems also. Right? So this is how merge sort works. Unlike divide and conquer, DP typically involves solving all subproblems rather than a small portion of subproblems. So DP tends to solve each subproblem only once, since the result of the subproblems are stored, which are later again is required, then it is going to reduce the compilation drastically in most cases. Complexity brute force it to do our end. order of one only. And the multi-stage graph also, this is the case here. All right. Let cost is I comma j represent cost of. We will discuss it in next video also, how this multi-stage graph works. All right. I think I discussed this earlier, but it's good to have this also. But if I only revise this later, or I think, yeah. So if I heap thing, it will be good. Again, so we will discuss it. All right. Thank you so much, guys. We'll meet you in the next video. Thank you so much.